Finding a specified term of an arithmetic sequence given the first terms. Here are two examples. Let's call the first example A, and call the second example B. And I'm going to show you something that's a little bit different from what you would actually see in a textbook. I'm going to show you a method that I teach to my calculus students. So what I'm going to do here is I'm going to visualize an arithmetic sequence in a very similar fashion to a straight line. So if the y-intercept here, let's say it's what, 0, 4. And if you look at the arithmetic difference, since the rise over run, if you look at the slope, sometimes we say rise over run. I don't really like that. I usually like up or down over left or right. In this case, our arithmetic difference is actually going to go up 6, and then we're going to go right 1. So if we go up 6, right 1, and then you go right 1 unit this way. And I could put another dot there, right? And if I went right 1, that means this unit here is 1. And this is the n-axis. So here's a straight line. But remember, in a sequence, we don't have a continuous straight line. In fact, what we're going to do now is I want to transform this ordered pair, 0, 4, 1 unit to the right. I would love this dot right here. And then for n equals 2, what should I get? Well, I should get the next dot over. So in this case, this ordered pair was 10 units high. This ordered pair, this is not the scale, by the way. This ordered pair is now 10 units high. I want to move this one over as well. And then with a sequence, all you have is actually these little red dots, right? And so on and so forth. So we're going to transform, let's say, this line here, that is a straight line. I'm going to transform it and move just these dots to the right. And how do I do that? Well, it's not too difficult. So let's call our sequence a sub n. We first have to find our slope, or in this case, the arithmetic difference. So the difference here is a sub 2 minus a sub 1, which is 6, which I already drew in the picture. First thing you need is the slope, 6. And then now I need to transform the x values 1 unit to the right. Well, in this case, it's the n values. How do I transform n values 1 unit to the right? I write parentheses n minus 1. Just like you did with your other basic graphs of like x squared or the natural log or the rational functions or the square root functions. If you wanted to transform the n units to the right, you would simply write the quantity n minus 1. You could also think about your conics too, right? When you try to label your center of your conics, you often had a transformation in there as well. Only thing left to do now is to indicate what would have been the y-intercept. So I want to start this at 4. So I'm going to add a 4 here. Add 4. And now we just got to state the domain. For what? N equals 1, 2, 3, ... Even though that is not my final answer, it's very, very important that I show that piece of evidence. This is now what? 6n minus 6 plus 4, so it's 6n minus 2. Once again, write the domain for n equals 1, 2, 3, dot, dot, dot. I'm going to circle this, even though I'm not done, because I'm going to need this. Notice 80 is in the domain, and so we're going to find a sub 80. A sub 80 is going to be 6 times 80, which is 480 minus 2. So that's 478. Therefore, the expression that you're looking for, a sub 80, got simplified to 478. I'm going to go ahead and circle this work as well, and of course the last line includes the final answer. Go ahead and try this technique with part B. You could pause the video right now and give it a try, and then if you need to check your answer, go ahead and hit the play and play the video. This is going to be b sub 1, b sub 2, b sub 3. Once again, let's find the arithmetic difference, which will also represent the slope of a linear line. In this case, 26 minus 17, we get 9. Let's call this b sub n. We're going to write the slope, 9. We're going to transform the n values 1 unit to the right. So I'm going to write n minus 1. And then we need the y-intercept. So the y-intercept is going to be, well, it would have been the y-intercept, but we transformed the y-intercept as well 1 unit to the right. So it'll be 17 here. And there you go. Remember to write the domain for n equals 1, 2, 3, 4, dot, dot, dot. 3 dots. Make sure you write the 3 dots. Now, let's simplify this. This is 9n minus 9 plus 17. Minus 9 plus 17, so 8 plus 8. Be nice if you check n equals 3 just to make sure it is 35. I'll let you guys check it. I already checked it, it is. We want to find the 51st term, so let's find b sub 51. Let's simplify this expression, which is 9 times 51. That's 450 add 9, so that's 459 plus 8. 459 plus 8 is what? 467. Yeah, that's right. So therefore, your expression b sub 51 is equal to 467. Make sure you show your work. Even though this is your final answer, it's best to show all the evidence that's involved. So I'm going to circle the whole thing. Boop. Same thing up here. I really should have circled the whole thing.